Today, fifth graders, we're going to be talking about rhombuses, which is another special type of four-sided shape. Yesterday, we were talking about parallelograms. And on the screen right now, I have the properties of parallelograms that we talked about yesterday. And to recall, the opposite sides of a parallelogram are congruent, meaning they're of equal length, and they're parallel. The opposite angles, those are the ones directly across from each other, they have equal measurements. Neighbors, those are the angles that share a connecting line, they can touch one another. They add up to 180 degrees. We can think of a parallelogram as a kind of knocked over rectangle. Today, what we're going to do is talk about a rhombus, which is a special type of parallelogram. And you're going to notice that from these properties that we talked about with parallelograms, there's going to be some similarities. So there's special parallelograms. So all of these rules are still going to be true in rhombuses. So in a rhombus, we're going to find that opposite sides are congruent and parallel. And in fact, that rule takes one extra step because it's kind of like a knocked over square. So every side is going to have an equal length, not just the ones that are opposite each other. However, it still follows the parallelogram rule where the opposite sides are parallel to one another. In a rhombus, all the angles that are opposite one another are equal, and neighboring angles are still going to add up to 180 degrees. Let's work on a couple of rhombuses together. So here we have a rhombus, okay? Every side here is equal to one another. And in fact, what I can do is add in congruency tick marks to prove that these are all equal to one another. And what I'm going to do is take a look at this missing angle measurement here. So if the measure of angle D is 65 degrees, what's the missing angle? So here I have a 65-degree angle. I'm going to move that into that corner. What are the missing angles? Well, I know that angle B is an opposite angle, so that's going to be 65 degrees automatically. And then I have to work on 180 minus 65, and I'm going to be left with 115. So angle C is 115, and angle A is 115. The next part of this question asks, if side CD is 5 centimeters, what are the remaining measurements? So if CD is 5, then all of the other sides are also 5 because it's a rhombus, so all of the sides in this shape are congruent. Now let's take a look at this rhombus here. If angle A equals 100 degrees, then we can figure out the remaining angles here, right? Angle B is the acute angle. They're neighboring angles. They add up to 180. So angle B equals 80 degrees, right? 180 minus 100 equals 80. For angle C, opposite angles are congruent. So if angle A was 100, I don't have to do any math with neighboring angles. I already know that angle C is 100. And as a bonus, this angle up here could equal 80 as well because it's opposite angle B. So right here, I've drawn another rhombus. And on this particular rhombus, I've tilted it a little bit so it doesn't look like a typical rhombus. But I can see that there are 1, 2, 3, 4 congruent sides. And one of the great things about rhombuses is that I can use properties that I learned earlier in the chapter. So I have to find this missing gold angle over here. And I'm not quite sure how that's going to happen. So what I need to do is, what I'm going to use right here is this little shade tool. And I'm just going to move up that cover so it's covering the top part of the rhombus. And now I have this figure left over here on the bottom. And quite simply, this is a triangle. But more importantly, I see that it is a triangle with 2 congruent sides. So it's a special kind of triangle. So right here, I'm going to have an isosceles triangle. So rhombuses, when they're cut like this, allow us to think about the rules of isosceles triangles, which is fantastic because now I can find out what this gold missing angle is over here. Now, using the rules of isosceles triangles, I know that this particular angle measure is 72. That's particularly useful information because I can now take 180 degrees and subtract the 72 away from it. So 180 degrees, and I'm going to take away 72 degrees, and I'm going to be left with 108 degrees. And that 108 degrees is going to be found in this angle over here and in this angle over here. And we know that these two angles are congruent. So they have an equal share of the 108 degrees. So 108 degrees, what I'm going to do now is divide it by 2, and I'm going to get 54 degrees in each of these angles. So my missing angle over here is 54 degrees. So isosceles triangles and using those rules allow me to find missing angles within the rhombus. And again, I use this shade piece up here to cover up the top part so it wasn't too confusing and that I could see that isosceles triangle hiding within the rhombus. I'm going to circle back to this slide over here where we had the rhombus with A, B, and C in there. And I'm going to show us this particular figure, and we're told that we need to find every missing angle in this particular figure. Well, this problem is also very possible. We have to remember rules for angles on a line, and angles in triangles, and angles in rhombuses. So there's a lot of rules coming into play right here. So I'm going to walk you through my thinking process for how we could solve this particular angle set. So over here, I know that this angle is opposite this one. So this is a 110-degree angle. So up top there, there's 110 degrees. Over here, I know what this angle is on this side of the triangle. And that's because I have angles on a line. So I might have to do a little bit of math here and do 180 minus 125, and I'm going to get 55 degrees. So this would be 55. I'm going to put that over there, 55 degrees. Fantastic. This angle right here, I know because it's a neighboring angle to this 110. So it's a neighboring angle to the 110, so this is 70 degrees. Now be careful. This angle right here is not a neighboring angle to the 125. It still neighbors this 110 down here because the shape itself is a rhombus. Now I know that this right here is 55 degrees. So now I'm going to draw in this angle right here and go to solve for this angle. Now my thinking is this is a triangle right here. And I know two of my angle measures already. So now what I need to do is solve for this missing angle piece right here. So if this is 110 degrees plus 55, that's 165 degrees. That means this is going to be 15 degrees inside here. And if this whole angle, the whole angle is 70 degrees, what I need to do now is find this part of the angle. So I'm going to do my 70 degrees minus 15 degrees, and I'm going to be left with 55 degrees right in here. So this part is 55 degrees. And now I've used the properties of parallelograms and rhombuses with neighboring angles. I've used it with opposite angles. I know that this whole thing has to be 70 degrees because it's opposite this right here. I used angles in triangles, and right here, I even used angles on a line. So there's many properties and rules to remember that will help me solve missing angles within rhombuses today.